Everybody, welcome to my very first session for the GroupBy conference. I was really honored when I received the email that I got selected, because it's a voting system, and that means that lots of people did vote for my session, and that makes me really honored to do that. And I hope that everything will work perfectly here and that you will enjoy the session. Before we start, a quick information or quick info about the code of conduct, but you can read it by yourself. What's for me really more interesting is to say a big thank you to all our core sponsors. I think that everybody of you know that without these kind of sponsors, these kind of sessions won't happen to you. And this is for free for you, and that can only be happen because we have this awesome sponsors here. Okay, excuse me. So what we are talking about is I would say from my experience from the field, not so common technique, it's partitioning. I think data warehouse people definitely know what partitioning is. But the key point here is that I have seen situations where we did optimization on OLTP systems just only by partitioning. When you hear today about partitioning, you will say, yeah, I think it's for big data warehouses, for quick load processes, all this kind of stuff. But I want to show you a few demos here, which are not only for data warehouse dependent workloads, but they are OLTP workloads. So if you want to download the session scripts, or you want to have the databases, which I'm playing around here, then you can download it here. These are the links. What I'm doing here for this session is I'm working with the customer orders database. This is a tiny little database, just only 9 million order details and 3 million orders, but I promise you that is definitely enough. The big database I normally use in workshops. Here we have over 600 million orders, and that makes, to be honest, way more fun. But on the other hand, I have to admit, that gives me way more time to sip at my mug of coffee, because the creation of the indexes of the partitions will take way more time. So good for you. That for me, I will go on with the smaller one with the customer orders database. A few words about me, but really only a few. Forget about the things what on the left side. You can read it if you download the presentation. The most important thing for you to know is my email address. This is a real email address, not a fake address. So if you have any questions concerning the data partitioning or anything related to the database engine, I'm really happy if you drop me an email, and I'm happy to answer it to you. Okay, that's about the commercial. And here is one important note for you. All use cases which I describe here, these are 4 of them. These are use cases coming from real world scenarios. So this is nothing what I had thought about, what can I show the audience? What maybe makes fun? Maybe a little pink rabbit is walking on the stage. Nothing like this. This is really coming from real world scenarios I had with my customers. The only thing what I have to admit, and that I think is clear, the customer scenarios have been really strongly simplified for this session. Otherwise, it would take more than 1 day for this. Here are my first use case. So as you see that I have 4 of them. The first is, from my point of view, one of the most interesting use case for partitioning. This is in a high transactional production environment. And my customer is coming from the pharmaceutical industries. And when they produce their drugs, they are using various production lines. So think of a big hall, lots of automatic machines running there and producing the stuff which makes you happy, I would say. Yeah. So the key point here is that when the drugs are getting out of the machine, they have to go under a so-called quality and assurance check. And these data are stored in a SQL Server database. The conception is very simple from the core concept here. You can see here that I have up to 16 machines. So these are the production machines. And there is one web server, a big web server, who is caching the information coming from the machine. So the so-called telegram data, that's the naming of it, the same as in automotive. And then they have several threads running on the web server and pushing the data into the SQL Server database. And they got extreme problems when the shift was starting and the production was going higher and higher, more and more was produced. And suddenly they were seeing that the send queue on the web server was full of not sent telegram data. And they checked out the web server and they figured out, the web server is fine. What they did, they added more cores to the web server, but they didn't fix the problem, because the problem was not the web server. The problem wasn't either the database server itself, that was a 32 core machine that was brilliant, but the problem was the database design. Because what you see here, this big red X, that is exactly the problem we have here. Thorsten was speaking about locking and blocking, and an X lock, exclusive lock, this means that someone is changing a record, is inserting a record, and if someone is blocking this resource, no other sessions can access this resource, and that was the problem here. So the data in the queue grew because the SQL Server could not save the data quickly enough. Not a problem of storage here. The problem is the latch contention. That was definitely the problem here with the database design, because the table was not able to scale. Another issue came up, but that was more a, let's say, a side effect of this. That was that the indexes were severely fragmented because the machine ID, so from what machine did it come, that was completely different with every single insert statement. The first one came from machine 16, the second one was coming from machine 8, and then again from 15 to 1, and so on and so on. And this was the problem what we needed to solve. And this is something I want to show you, first of all, how you can see the problems. And the second thing is, when you identify the problems, how you can solve this. Ready, steady, go. So here is my my solution, my SQL Server management solution. The database has been created, everything is fine. And the first script, the first demo is in the script 110. I hope that the fonts are large enough, but I think it will. Otherwise, you have to go nearer to your screen. So what will I do? The first step, I create my demo database. And here is my, as I said, very, very strongly simplified demo table. It's called machine protocol. What I store here is the machine ID. So from what machine is the telegram coming, the timestamp, and the content of the telegram. And here I create then a unique clustered index on this table on the machine ID with the timestamp when it gets executed, when it gets inserted. And here I have a so-called wrapper store procedure, which makes it way easier than for me to simulate workloads. You see that it's very simple. I hand over a machine ID, and then I only insert the rows, so the telegram data, which is here for information only. Okay, so this is my wrapper, and now we can start. So what will I do here? The first thing what you always need to figure out, if you're facing some problems with high transactional systems and you're not sure about, is this a problem of the workload? Is this a problem of the hardware, or maybe of the database design? What else? You have the possibility to figure this out by using extended events. I need to be honest. I think 3-4 years ago, I was not so happy with X events because for one simple reason, I did not use them. I did not know how cool they are. X events are so brilliant. They way better than a profiler because they way faster and they are lightweight. And what I'm doing is here now is, because that is the first thing what you as an architect should do, try to figure out what's happening when the workload is starting. And my first guess when I heard about the problems was storage, because it might be that they have slow storage, that it could not write in fast enough. But when I came there, I saw that they had flash cards in it. So that definitely could not be a problem. And then I turned to another idea and said, well, okay, it must be a problem of locking and blocking. So what I do for this case here is I'm now monitoring the, excuse me, I'm now monitoring the transactions and check whether we have exclusive logs, shared logs, all this kind of stuff. What I'm doing here is, I want to explain this to you, that's very simple and easy. The first thing what I need to know is, so basically I work with the database ID instead of a name. Here for demo purposes, it's very simple. I say, okay, go for the database name DemoDB. I can strongly recommend, really strongly recommend a session from Aaron Stiletto from SQL Skills about X events with the problematic of filtering. You need to be quite careful when you create your X event sessions and when you think about the where statement, how you should define this. So what I'm doing here is the first thing I'm monitoring the wait info. So for what do I wait? But I will only wait for a status which takes longer than 1 millisecond. To be honest, to insert one single row in less than a millisecond is, from my point of view, absolutely okay. If it takes longer, there must be a there must be a problem. And I say, please give me only the wait statistic or the wait info for sessions which are waiting longer than 1 millisecond in my demo database. And to be honest, yeah, this is a little bit annoying here. You cannot use wordings, but you have to use the type IDs. Long story short, we are waiting for exclusive logs, shared logs, and so on and so on. And these are the wait types. And then I'm running, or I add another event called latch suspended, suspend end. So that means when a process holds a latch on a resource and it gets released after a dedicated timeline, for this example, the duration 1 millisecond, then I want to have this information too. And as I said, there was one point what was really interesting for me. We had lots of page splits. A page split does occur when you insert a new row into a data page, which is completely full, but it needs to be in this page, and then a page split occurs. And this is something what I want to monitor. I save everything in this page file, in this file here, yeah, and then I let it run. So that's okay. So now I have here in the extended events register my session. It's called 110 extended event for high transaction. That's what I need for the analysis of the process. Otherwise, to be honest, there is nothing what you can see otherwise. I reset my performance counters, oh, my wait stats, sorry. And now I do the same as Thorsten did before. I run an O-stress process. And that makes it, by the way, a little bit difficult. How can you, with one O-stress session, simulate 16 machines? The problem is here that my stored procedure does not, I only give the machine ID as a parameter, but so that means for me, normally I should run 16 O-stress processes. To be honest, when I start the first and go to the next window to open the second, the first one is finished. So what I do is a little trick. What I'm doing is I'm running a workload, a batch file. This is this one here. And you see here that I start the machine number one, which calls O-stress, the stored procedure with the machine ID is equal 1. and 2 and 3 and so on, every single process inserts 10,000 rows into the table. We do it in a silent mode because we don't want to have the output in my command window. So that is the trick here. So this one can simulate 16 machines. Okay, I do this. Go into my command box. Here we are. And then we go for this. So now the system is starting 16 machines. And to be honest, the most important thing here to know is that you please see what happens with the time when the processes are up and running and until they are finished. In the meantime, I'm going here and checking, do I have anything waiting? And you see here, this is something where I wait for, write log that, it looks good, that is okay. The dispatcher queue, this is not necessary, however. And so when it's finished, hopefully it will work. The problem is that I'm using Zoom, and Zoom is a very CPU hungry application. It might take a little bit longer than it normally is doing when I do this test here. But however, I think definitely this will work. Here you can see in the meantime what SQL Server is waiting for. And what you see is very interesting because this is a query running for system OS await stats, and I'm filtering for write log, page ledge, all this kind of stuff. The most interesting thing here to see is that SQL Server mostly is waiting for the write log wait time, which is, by the way, if you're dealing with OLTP systems, absolutely perfect. This is not something where you should be concerned about, because when we are writing 160,000 rows, that is absolutely clear that we have to wait a little bit here. But what's really important is, first of all, this one here, but there is an explanation for this. The SOS scheduler yield, keep in mind, the people who are familiar with wait stats knows immediately what does this mean. When you're in a supermarket and you're standing in a queue, in front of you are lots of people waiting for the cash desk, and there is someone at the cash desk who has a huge big basket of things, and you know, gosh, this one will take hours. Don't worry, what SQL Server is doing, it gives him only a small quantum of time, which is 4 milliseconds. When the 4 milliseconds have been exhausted, then the guy has to go back to the end of the queue and go with the rest of the goods back to the cash desk. This SOS scheduler yield is recording how long will you stay in the queue up to the next time you have access to the CPU. Here, this is, to be honest, this is a nightmare. But the reason for this, especially here in my scenario, is I'm running a very small, tiny Dell 13 XPS with 4 cores, but I'm running 16 processes, and they are hammering on my DB. So that is okay. What concerns me more is exactly this one here, the page ledges. A page ledge as a ledge protects the structure. And from my point of view, this is a problem here. Let's see what happens here. And this is really, really interesting. By the way, that is really cool. My tests without Zoom running in the background was around 20 seconds. So you see that Zoom is using heavily my CPU. It's eating my CPU. However, look to this, and this is really interesting. When we go through the processes, you will see here that from 51 seconds, it is growing. It's taking longer and longer and longer, up to 58 seconds. So that means that we have, in total, for exactly the same workload, a difference of 9 seconds in between. And the reason for that is very simple. Think about a situation where thousands of people are going to one big event, let's say for a soccer game. To be honest, I think the problem is not when you're in the stadium, but in front of it when you want to enter it. And that's exactly the problem here. 16 processes are permanently want to write data into the database. And the problem is here, the database cannot scale for several reasons. Let me show you what happens here. The very interesting thing to know is, and now we come to the evaluation of my X event, the information about the page splits. You remember page splits, page is full, we have to go to the next one. And what I'm doing here is I'm now taking my X event, my recording of my workload, and what I'm doing here is I'm now evaluating it. And the only thing what I want to see here is the action split for insert. That characterizes a page split. But the good thing, or the real interesting thing, is this one here. It looks very harmless, but it isn't. What I'm looking is, I want to know, is the next page immediately after the first one? Then we are talking about a good page split. If the page is full, then we take a new one and we insert and that will record a page split in the same way. But if the difference between the two pages is more than one, then I definitely know that must be a page split, which is a bad one. Because then we were pushing a data record into the page, and the half of the page needed to be moved to way outside at the end of the index. Let's see what this result is. And it's really interesting to see. And keep the numbers, please, the numbers in mind when you see this. It takes a little bit. Yeah, here we are. Look to this so-called split jump. What I record here is, you see here in the row number 2, there is a page split, which means that data from the page 295 have been moved over to the page 352. Definitely a bad page split. Look to the numbers of page splits here, 21,500 page splits. So that is definitely one of the problems we have with the system here, because the transaction log is way more working on page splits than inserting rows. 21 just only for 1 minute workload running. Oh my gosh, that is really a long time. So this page split problem you can definitely see here with when I run an investigation on my physical index stats. Look to this. Whoa, 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 whoa. Cool. So here we have our 160,000 rows. Perfect. Brilliant. We are using 22,000 pages. Absolutely fine. But look to this. This number does mean that, to be honest, not just one page is following the next one or the previous one. We have permanently jumps in between. Though that means when we read the data, we need to jump from page 1 to page 100, back to 5, then to 200, and so on and so on. And that makes the system slow. But we are not dealing here with problems with reading data. We are dealing with problems writing data. And the transaction log gets filled with the page split activity. By the way, that only for you as an information. If you normally insert a row, it just only take the payload of this here, insert a row, block the page, insert the row, release the page, fine. But if you have a page split will have an average transaction consumption of 16 kilobytes. 16, wow. Yeah, so now 21,000 by 16 kilobytes. Yeah, we are so happy to have a very fast storage here. That was what the customer was thinking. But as I said, we cannot scale. We cannot scale because we are using the transaction log way too much for a page split. Second thing is that we are all hitting our database file or the table on specific pages because everybody wants to write the data, and the problem is here a locking problem. So what can we do? The key point here is, and this is something when you're dealing with, or if you have the idea to work with partitioning, so not from the data warehouse perspective, you need to think about what is the bottleneck in your table. The bottleneck in our table here is definitely the machine ID. So every single machine is writing data or is sending data to the web service, and then the web service grab the data as they come in and push them into the database. So what we're doing is the following. The web service now is writing the data in the same way as before, but each single process will only write for a dedicated machine ID, step one. And the second thing, and the way more important thing is, for every single machine, we now create a dedicated partition. So think about this. So if you're not so familiar with partitioning, long story short, we take our table and we make for every single, let's say, group of data, a separate table behind, a separate allocation range for this. And here you can see that I create now in the next part 16 partitions, and this is something you should always take into consideration when you're talking about partitioning. Do not put everything on one big drive. That doesn't make sense. I see so often partitioning and they say, and all on primary. So that works. Absolutely. It will slightly improve the performance for this workload. But the key benefits you don't achieve here, because we want to write on separate files. That is way faster. And if you have a perfect environment, or let's say your customer has so much money that he can throw it over you and say, here is my money, take it. Then he has dedicated drives or mount points for each file. But that depends on the transaction sizes, on the transaction numbers. So let me demonstrate to you how this works. So first thing, I truncate my table because I don't need the data anymore. So the drugs are out. And here, what I'm doing now is, long story short, you see here, let me put this away. Okay, so what I'm doing here now with my demo database is, from machine number 1 to machine number 16, I now add a new file group per each machine and add a dedicated file to this file group. The only problem I have here for a good demonstration is, sorry, I do not have a big server here with lots of storage in the background. So I take my little small tiny laptop, but we will see that it will work better. So here we are. You see here are the statements. I just printed it out. So alter the database, add a file. So add the file group, then I add the file to it. And you see that's 128 megabyte. That's okay. And so this is the first step. Let me show you how my system is now looking. Go for this. Here is my database, the demo DB. Go into the properties and look to the files. And you see here, now my database has a file group machine 1 to 16. And every single file which I have is located here. Come on, this is a logical file name. This is based for rows. There is nothing here, absolutely nothing here, which is intention that we use it for partitioning, because the only thing what we do in here is that we have multiple files. The problem with this is because lots of people think, well, yeah, add more files and everything is, the problem is gone. No, the problem is not gone, because once again, the storage is not the problem. The problem is the bottleneck is the table itself. So you can add more and more storage to it. The only one who would be really happy about it is Janice from Pure Storage. Yeah, when you buy the Pure Storage systems. So that is not the solution we are looking for. The key point now is, So, and I really hope that you are familiar with partitioning, because I don't want to go too much into details how this works, but long story short, for partitioning, the first thing what you need is, you need to have a partitioning function. And this partition function describes nothing else but the values you want to separate, you want to use in partitions. You see here very perfect that I'm using my machine IDs 1 to 16. So I create my partition function, and now comes the next thing. I need to bind the function, which is a logical layer, to the physical layer, which means the files and the file groups. Therefore, I'm using a so-called partition schema. And look to this partition schema. The key point, what you see here is that I have 16 plus 1. As I said, not too much into detail, but the reason is we need to have one more free partition where we put data in which do not belong to the values I want to distribute over the files. So here is my partition schema created. And by the way, that's it. So now we can implement partitioning. Yeah. So what will I do? The first step, what I'm doing is I drop my index on the table, because this is not a partition table. Not only when you add a few functions or schemas or something like that, you can say, hey, I have partitioning. You have nothing. Yeah? You have just only prepared for partitioning. To make a table partitioned, you need to move the data or the table on this partition schema. So you see here that I create now a clustered index, whole table, from the table machine protocol, which is the machine ID and the timestamp, on this partition schema based on the machine ID. So whenever in the next demo, a machine ID is coming in, it gets automatically distributed over the schema into the right partition. Then I go for this, and here is my information about this. You see, this is my table, my index, this is the only one I have, the index, and here you see how many rows I have in a partition, currently nothing. And look to this, you see here the boundary, that means everything, what is the machine ID number 1 goes automatically into this partition, the 2, the 3, and so on and so on. So everything is prepared. And now we run this again. I clear my wait stats. I rerun my X event. Go for it. And then we start this session again. So, okay, I know that it will take 58 seconds. If we do not see a huge discrepancy, that means that the system is now running very, very, very slow. That is, as I said, because of my CPU, which is yelling loud, saying, stop Zoom, stop Zoom. Yeah, but I have to wait for this. But what I can show you is what the system is doing in the meantime. Look to this here, SQL Server. And I promise you, you will love this when you see this. Look to the perfect distribution of data. See what SQL Server is doing. We are writing simultaneously over all 16 files. And now think what would happen here if we could have your own controllers and own storage per each file. The system will fly. Yeah. So this is a really cool thing here. So the distribution will definitely go better. And I hope that it will finish right in time. But in the meantime, I can check what are the weights. And look to this. Do you see any page latches? Nothing. Absolutely nothing. This here, by the way, is because I have 2 less CPUs here. 16 processors are hammering my system. I have just only 4 cores. Yeah. So this is definitely people. So maybe the younger people under all of us here, so I'm over 50, the problem is I don't go into a club nowadays. I was going into a discotheque for the youngers here, yeah? So think about this. When the club is full, then you have to wait outside. So you hear the music, but you cannot come in. That's thread pool. And the key point here is that we have 16 processes here permanently hitting the system. It's going very fast. So the problem is we don't have worker threads here, which can be used for doing the process. But two things are very cool here. The right block is the mandatory wait stat here, which is perfect. Look to the suspension time. It's less than a millisecond. Wow. And my scheduler yield was going down from 100, that means, wow, 10 milliseconds, down to 9 milliseconds. So that means that the processes are running a little bit faster here. So let's see whether we can see it here in results. Oh my goodness. This is a demo gun, right? Normally I would expect here then, let's say 50 seconds, but you see it's 55 up to a minute. But I promise you, I promise you, it is faster. It is definitely faster. You have to believe me. There is another point. So you remember we had some problems with the fragmentation. And now look to this. And I think the really experienced index guys here, I saw Hugo is here in this, is watching this session. Look to this. Does it look great? We do not have any more fragmentation. And that is absolutely clear because now every single row gets inserted into its own partition. And whether we have an ascending key there by machine ID and the timestamp, it doesn't matter. It goes always in every single partition to the very, very end. And that does mean, as a conclusion, that we must see less bad page splits. So 21,000, let's see this. Oh, come on. Yeah, that looks great. 7. And that is the reason why the system is way faster than before. Instead of 21,000 page splits, we only have 7 here, which are not one after each other. And believe me, 21,000 by 16 kilobyte saved transaction amount makes your system faster. Believe it or not, that is absolutely, this is really oh, sharp, come on, go for it, yeah. Okay. So then we clean the kitchen, everything is fine so far.
While you're cleaning up, we have 2 questions, if I may. Madhu asked if it would help with the problem if we use a clustered index and the identity field as a clustered index and the machine ID as a non-clustered index.
Oh, yeah, that is a good question. So the question is that you use an independent identity value as a clustered index column, right? Right. Does it mean this?
I think so. Maybe he can clarify.
To facilitate further, that is better. All right, Hugo is, I will come later on to this. So basically, if you, long story short, if you're using identity values, identities cannot scale. This will always be a problem. So that means if you're using a dedicated column just only for an identity value, then it will not scale because the problem then is that everyone wants to insert at the very last point. Let me check. Yeah, if you partition it, then the statement will go into the partition with the highest identity. Does it? I don't think it makes really sense here. It just only blow up your record. And if you're dealing or if you're looking fragmentation, if you're dealing with performance of writing, then I would take my row as small as possible. Yeah. So there's the next here, there's fragmentation problem was not really deal with partitioning, but instead bad clustered index. This comes from Michael. Let me check this. Does fragmentation problem was not really deal with partitioning, but instead bad clustered index? Yes, yeah, that can truly be, because we have an in-clustered index on the machine ID and the timestamp. Sure, that cannot scale, but if you want, or if the vendors say we want to have this here, you cannot change the clustered index, then partitioning can solve these issues here. Definitely. Any reason, Hugo, any reason to have the partition function used values up to 15 only, or was it? That doesn't make sense. I think it was 16, but I will check this.
I think he means you did 16 partitions and one primary, but the rest of the data, but you could do just...
Yeah, I could have another one for machine 17, something like this, but this is only for demo purposes. Okay. Next one. This was my use case number 1. So we had a performance improvement up to 15%. We were way faster then. And you know what a good thing is? They are producing different kind of drugs. Let's say aspirin, and on the other hand a ibuprofen and something like that, and it depends on the amount of drugs. What we can do with this here is we can scale it now, because let's say we have on the machine number 3 a way higher production interval than we have on machine 16. Then we can scale it by adding another file just only to this file group to write faster. Yeah. Okay. So the second one, yeah, that is cool. The second one is the following. A customer is a retail company, which is here in Germany, one of the big 3. This is the only thing what I can say. It's a retail company that load key figures, so product and sales of all cash registers per site into their data warehouse. It goes every single night because they need to create reliable appliance for the supply chain of the stores. What does this mean? Let's think about a really big supermarkets, and what they are doing is every single, that's Unix systems, so they're creating from every single cash desk the complete output of everything they have booked over the day. That goes into a CSV file, and from the CSV file then the system is getting the data and pushing them into the database server. And that goes every single night. So what I'm doing here, again, with 16 warehouses and with 25 cash desks in each warehouse. This customer has just only in Germany over 1,200 supermarkets. And every single supermarket has I would say an average of 10, let's say 15, 16 cash desks. So, and the number of bookings depend on how long the cash desk was open. So what I'm doing is here, I'm preparing, I do not run the bulk load, but we will do the session here, the demo here at the database server where we have loaded the data. The problem is here, that was the issue where they caught me, that the calculations have not been possible while the import is running. And keep following in mind, the supermarkets close at 10 p.m. and at 3:30, 4 a.m. in the morning, the trucks need to be prepared for shipping the stuff to the supermarkets. So parallel processing is not possible because of lockings. And this is how this works. So what I want to do, I do not have the CSV files here. What I'm doing is I prepare in my staging schema a table called cache activities. Here in this cache activities, I have around 9 million rows, which represents the data coming from the CSV file. And then I have a wrapper stored procedure called import cache test data, and they should be inserted into the data warehouse. And the problem here is that this one is pushing the data, not only in reality, not 9 million, but over 900 million rows into this, while on the other hand, the processes are running to calculate the supply chain. So what things need to be loaded to the truck to send to the supermarkets. And let me show you how this works and what the problems are. So we go for this. I again create my demo database. Okay. And you see here that I'm creating my schema staging. I have a table called cache analysis here. And then I fill the CSV files coming from demo data into this cache activities. It takes a little bit, but not too much time. That is okay. And here, come on, get the data. You see, Let's SQL Server is really hard working. TempDB, and this is because of the process of the insert here for the sorting. Then we should run into here it's writing. Okay, it's done. Perfect. Thank you. So these are my data. You see here that in the warehouse number 12 and the cache test number 13, at that date, we had the article number 16, which is called dark gray, and they had 9.07 items on the belt and a total in an article price of 35. Oops, where is my mouse? Come on, here. Okay. So I create a clustered index. The index is just only here for me. That was in reality, it's a heap table, but I'm just doing it here for just only one thing. I just want to load a little bit faster. I don't want to wait hours here for the loading. And after this index has been created, we want to have a look to the distribution of the data. In the meantime, so it's executing. Forget about this. Okay. In the meantime, I will have a table called cache analysis. This cache analysis, this represents my data warehouse. So my data warehouse table. Okay. So, and you see that here I have a payload from 200 characters. This is on top of it. Here is my distribution of data. So every single warehouse, you see here, warehouse cache test, these number of activities, 88,000 activities, also on. You see that it's unevenly distributed. But the key point here is that it depends on how long the cache test was open at the opening time. So now I create this table. This is the source table where the data should be stored in. So here I create my warehouse, my clustered index, sorry for this, okay. And what I'm doing is just only for now for monitoring only. There's nothing which belongs to the problem. I just only want to measure how long did it take. So I go for this. It's a log file that is very easy. You see here now, this is my stored procedure. You see, I did comment it out here. The reason is I had before I run this session here for GroupBy, I had a session with another presentation software, and that was running so ugly that I decided not to put it in. I wanted normally go for every single cache test to simulate a little bit of workload. What I'm doing now is, first thing, I'm recording my start of the process, and then I insert into the cache analysis only the data one-to-one from the staging to the data warehouse, one-to-one. And afterwards, I will update when I finish. What would be the normal perception here? When I run this simultaneously with multiple threads, I would expect that every process will take the same time, nearby the same time. Let's do this. I create this stored procedure. As I said, just only for producing workloads. And then I run the load process. Yes, oops, that is copy paste. Copy. So you see here that I do now a different workload called workload 2. And yeah, let's start this. So now we go with 16 cores, 16 processes again, and try to load the data. And what we'll see here now is a very interesting behavior. So the first one is finished. Wow, 8 seconds. 8 seconds, but the second one will never come back. This problem, what we have here is we are running in a complete blocking scenario. When I run into this, come on, let me see this. Yeah. So you see here that we are running with lots of processes in a, oh, excuse me, in a blocking scenario. And that does mean here, oh gosh, 9 processes are waiting for something. Yeah. So, and these are processes, oh, not 9, oh, 10, 11, 12, 13. That looks funny. And look to this. The first one was finished in 8 seconds, then 45, 44, 47, 48. And now we are going on and on up to 55. By the way, this is a good thing. I saw differences up to 10, 12, 20, 25 seconds. The problem here is that SQL Server, or that we have too much data we want to load with one single process. And that leads to a big, big problem. Let me go to this one here. Scheduler is okay, that's clear. Absolutely, we don't have to talk about it. I'm running out of CPUs. But here, this one is important. The IX, intent exclusive. So SQL Server wants to set a lock on resources, but it didn't work. So why didn't it work? So the key point here is when I look into the workloads here, you can see that it was growing and growing and growing and growing. It was going every single time, it was going more and more and more and more and more. So what is the reason behind? The discrepancy between min and max is tremendous. So from 7 up to 56 seconds. So that's the bandwidth of the load process. The key point why it happens, that I truncate the table, is, and Thorsten mentioned it when he was talking about the in-memory objects, about log escalation. I think log escalation will be okay. You know what it means. Let me show you what I mean. I start my transaction, and then I load the data. Let's say this is the very first process which jumps in and says, yeah, I'm number 1. I fill the data. So now SQL Server is grabbing the data from the staging area and pushing them into the table. When you look into the logs, you will see here, yeah. Look to this. My object, cache analysis, the warehouse log, it's okay. That's only for the, for the recording. But look to this. My table cache analysis is exclusively locked. So, and now think what will happen if there are 15, in the case of my customer, it's over 50 processes are behind and saying, I want to write, I want to write. And they can't because this process is blocking the table. Let's say this one will step out, say, okay, it's done. What will happen? The second one steps in and say, oh, now I'm in, I lock the table. And so that is the reason that for every single process, when we are simultaneously running 50 processes, the last one is, how do I say, yeah, he's the stupid one. Yeah, because he has to wait before 49 other processes have finished. So the key point here is that we are loading too much data, by the way, and yet now someone can say, well, okay, then load it in fewer rows, put always 5,000 into it. But come on, a data warehouse where you insert 5,000 rows and go in a loop? No, not with us. So what we want to do is we want to figure out how we can make it better. Roll it back, checkpoint, and we run exactly the same here as for the first demo, but in this time here, you will see it looks absolutely identically. Let me do this, go for it. Here, and then you can see that everything is done. 16 files, yeah, it's super, super good. Yes, here it is. Everyone has its own one. I create again my partition function as I have learned in a session about partitioning. I create my partition schema and I create my index on this partition on the warehouse ID. We would say, brilliant. Now we do this one. No, stop. No, not yet. Not yet. So here is my partition information. We do not have any rows in it. That looks good. 0 rows. Perfect. Reset the counters. And now we run this query again. And we all hope, because our partitioning is the silver bullet which will solve my problems. Let's see. Run, run, run. So yeah, that takes a little, 16 processes, and come on, gosh, yeah. So now it's running. It's running, and it's running. It doesn't get better. Oh, 22 seconds. Cool. So in the meantime, oh, now it's working. 22, 22. Seems to be a little bit better. But I promise it isn't. These are the values I would expect without my CPU project here. Because when we look into the weight stats, again, you can see that we will have, is it finished? Yeah, it's finished. So, but we can see it's here. Right log, here is the page lag. It looks better. It looks better. But the problem is, and unfortunately, we cannot see this here from the weight stats immediately. The key point here is that we will have always problems with the different weights here. But it's nearer to each other, 19 up to 30. We are better. I think everybody can see here we are around 15, 20 seconds better. But there is one more problem which we did not resolve. And this is the key point here, what I want to point to. You see the difference here? So it's up to 11 seconds. I truncate the table. And here comes one point, which, to be honest, makes me, yeah, I'm a little bit annoyed about this. I'm wondering why Microsoft does not do it automatically. When you're working with partitioning and you partition your table, it does not mean that the lock escalation will automatically break down to on a partition level. That is the problem here. So when I start again my transaction and I start my import process here, so it now goes just only for the warehouse one. And I promise you that is really only for this first partition. You will see this one here. Look to this. So what does this mean? Yeah, we were a little bit better because we distributed the writing to different files. Seems good, good idea. But the key problem did not solve here because the cache analysis, the table where we write the data to, is blocked. It's with an exclusive lock blocked. And that means that our loading process will not scale. It is better because of the underlying disk layout, maybe, but it's not better from the perspective of locking and blocking. So what we need to do, and this is something what I see when it's coming to partitioning, what I see sometimes that the developer did not work for it, they did not activate it. If you want to make sure that when you load data into partitions and you want to make sure that SQL Server will only do a lock escalation on a partition level and not on the table level, because you want to distribute it by multiple processes, you have to set for the table the lock escalation from table to auto. I do this. I truncate my table. So now SQL Server detects, and as I said, I'm wondering why is SQL Server not doing this. So let's run this again. And now it should be better, around 10% better, hopefully. So the demigod needs to be with me. Yeah. Oh no, this is fake. This is fake news. 1 second. Do not believe the system. This 1 second is just only because when it started, now it was starting everything, and now it's recording. Say, hey, the first one is just only 1 second. That's not true. But you see, the system now, I hope that it will not go over the 30. This is my goal here, but it will, you see. Okay, but I hope that you can see here that lots of them are under this 30, but unfortunately, lots of them are over the 30. Let's look for this, what SQL Server is doing. So the weight, again, log flush here, but here's my exclusive. It's nearby 10%, but the key problem here is also, I would say, yeah, it's hard to explain why this happens here. Basically, it shouldn't. It shouldn't, because when we check this, come on, where's my mouse? Here. You see here, this is the differences in between. You see that it's, to be honest, nothing really has changed, but you have to believe me that it will, and I can demonstrate this to you. Truncate the table, and I just start only my one transaction. And you will see that SQL Server will not have an exclusive lock on the table, but it will have here on the cache analysis an intent exclusive lock, which is compatible to other intent exclusive locks. But we hold an exclusive lock just only on this partition. And unfortunately, you have to believe me, the system can way better scale here. Because now we can evenly write simultaneously into our database files. And that makes it so comfortable. And that's where what you should think about when we are talking about partitioning. So key value here, or point to remember when I find my mouse here, the point to remember here is when you work with partitioning, then please make sure that you do not forget this statement. And in this particular case, that has not been said. Okay, this is the second one, save it, and we go back into, I go back, come on CPU. You cannot believe how hot it is here in my office. My CPU is burning down and my, oh, whoops, what's that? Yeah, that's true, yeah. That's true, I have to roll back. that's when we are too fast. Go for it. So now it's done. Okay. Okay, good.
So we have 27 minutes left. Hugo did clarify his question.
Yeah, let me check this. Yeah, you had a partition function with values 1 to 16. That results in 17. This is correct. Yes. So you could, if you want to, change it to 15. But yet I know what he wants to do. Yes, Hugo, yes, you are right. It's just me that I didn't understand in the first step. Yeah, I wanted to separate really every single machine ID that it is okay that everybody see, hey, this writes into 16 and not in the primary. This is the reason for that. But yes, the best practice would always be have for every single, let's say, partition key, your own partition normally would do called 17 for the next one. I will show it later on here with the next demo when we do a partition split. Yeah. Okay. So Thomas, how much time do we have? 20 minutes?
25. Yeah.
25. That's okay. Good. That's okay. So here is the problem. Yeah. So log escalation prevent. Oh, there's a little typo in log escalation prevented the data records from being entered into the table at the same time. So every single split had to wait until the first one did release the X log. So that is the key point here. The key takeaway: use log escalation equal to auto if you want to load simultaneously. So 20 minutes. I would like to skip this one here. Let's go to the more interesting thing, management of big databases. So when I started my career as a DBA in a big bank here in Germany, the Big Blue, so everybody knows what bank I mean. It was in 2008, and our Microsoft SQL servers were just only the tiny little brothers of the Oracle databases. So our biggest database we had back in 2008 was around, let's say, 400 to 500 gigabytes, nothing more. When I had a look to the Oracle system, they were way over 20 terabytes at that time. This was a huge difference. So for us, everything was so easy. Think about a backup and restore. There was an emergency. Hey, someone was calling. No, not calling. Stop. In 2008, in a bank, they called us and said, hey, Uwe, can you please restore the production system? We had a problem. And Uwe did. Yeah, because it was 2008. We were so happy. We were friends. So the business was our friend and so on. But then in 2012, that was not so easy anymore because then we had processes called ITIL. So, however, a restore of a 500 gigabyte database was very easy. It took maybe 30 minutes and then everything was okay. So 30 minutes downtime, if the SLA will cover that, that's fine. So nowadays, we do not deal with 500 gigabyte databases. So this is, for example, one of my demo databases, yeah, from the bigger one. So what we always now need to take into consideration is the recovery point objective, the time objective, but this is not so important here, the recovery level objective. The RPO and especially the RTO, these are the key components, what we have to think about when we are talking about big databases. Nowadays, I have one customer in Germany, where I'm helping them with I think 12 or 13 terabyte database. 13 terabyte, this is really a huge amount of data. And the problem is when they have to do a full restore, it takes around 2 hours. But what is if, and this is quick, by the way, this is really quick. They have incredible fast storage. But what is if the business say, hey, DBAs, like Scotty in Enterprise, yeah, Captain, we have a problem with the machine. Scotty, I give you 4 hours to fix it. Okay, boss, give me 30 minutes and I fix it. So this is the key point, what never happens with databases. The problem is if the business has an RTO of 30 minutes, for example, you will never ever get it up and running within 30 minutes. Impossible. So this is something what you need to take into consideration. So RPO, RTO, and RLO. So what is the consideration? We have as a DBR lots of challenges. It's required to back up is it required to back up the complete database every night? Think about the storage, the waste of storage. How long does the backup take? How much storage does it consume? So maybe differential backups will help. Maybe. Why not run backups against hot and changing data? That is the key point here. And so there comes the point. We use partitioning for the read, write, and the read-only file groups. The same question comes up for restore. Can a full restore of the database cover the SLA? I would say in modern environments, which I see so day by day, I would say definitely no. And the DBAs do not have any concerns. They say, well, no problem. We have availability groups. Or better, a joke, an afternoon joke. Hey, DBA, what do you think? Will your SLA be covered? No problem. I have running a SQL Server cluster. Cluster at high availability. So it's so funny. That doesn't work. Yeah. So what we can do is then we can use partitioning for a way better maintenance and management of these big databases. And let me show you how this will work. So I have to jump over to the file group restore. And here we are. So in the first step, what I'm doing, I create my demo database, put 3 million rows into a new table, and then I go again, create my partition function. In this case, by the way, it's on the order date, and I have 20 years of data here, and I put in every single year. And then I create my file groups, my partition function, and then I create an index on the ID and on the order date, and I push it on the partition here. So, okay. In the meantime, a file group restore, by the way, this is a very cool thing. The actual situation as my database is now, we have here my big table, and my data are now evenly distributed to all these underlying files. And now we come to a point where we say, hey, people, I don't think that we need to write more data in older years because they are closed. So what will be if we say, do this one, make the older years, so the, let's say, not hot data, cool, not hot data, make them read only. I hope that a few of you are DBAs here. Think about the following good things here. First step. You don't need to run an index rebuild on the read-only file groups. That takes you, that gives you way more time for database maintenance on the active part of your data. Think about statistics update. If you run, I've never seen this before. I have one customer with around, it's 900 billion rows, and the statistics update with a sample rate of 10% on a very fast storage. It was taking nearby 40 minutes. I couldn't believe my eyes, 40 minutes. So think about this. And now when you think about index rebuilds, index reorganize, and statistics updates, and you just only have a very small little service window of, let's say, 3 hours. I promise you will never fix it. You can't do this. They are doing lots of funny tricks with this. Yeah? They pick the biggest one manually and say, okay, do only this one and skip the normal maintenance. All this, by the way. So we are finished here, and now my system is ready to run. So 9 million rows into it. And here is my, what? Stop is DemoDB. I'm in the DemoDB, hopefully, yes. Let me check this. Go for it. Database, refresh. No, it's okay. It is okay. File group. So the partition is created. Index is created. I love it when it works. What? One moment. The good thing with my scripts is I can restart them whenever I want from the beginning. So create my demo database, put 3 million rows into it. Then I create my partition function to add multiple file groups and files to my system. Then I create my partition scheme and I create a unique index on this. Okay, and then everything should be fine. Oh yeah, so and now okay, this was only the information. I'm wondering why it's not working, but you go into this, see it in here, no problem. You look, see here, everything is now inserted. Good. And now we check the problem. The first thing what I want to do is I want to mark the file groups for the year 2000 up to 2017 as read only. You see here now that these file groups are marked as read only. My database is just only in a simple recovery module, by the way. Yeah. So these both are active. Good. Now I make a backup of this database, and then the problem is starting. Someone is unfortunately dropping the database. So now the emergency call is coming from the top management and say, hey, DBA, we have a problem with our database. Restore this. Yeah, and then you start. And I think that you might be a little bit nervous because you know, oops, there is an 11 terabyte big database. And the management say, well, it depends all on your salary. So if it's finished in 30 minutes, I double it. And then you start crying because you know, I can't do this. And the problem is the manager knows it too. So what will happen? Let's check this. I say statistics time because I want to measure how much time it will take. And by the way, this is a tiny little cute database only, but have a look how long it will take. 3 million rows only. Do the backup, go for it. Yeah, this is okay. And here, it was taken nearby 4.5 seconds. It's okay, yes. But the problem is here, the people don't use the actual data. What we did, we restored, excuse me, we restored the complete database. But that's what we don't use, what we don't need. Better would be this. And now your salary get doubled. What I say to the system is, hey, SQL Server, please restore all my read-write file groups. That's, by the way, the only way you can do this in a database running in a simple recovery model. Yeah, we are not talking about partial recovery here, but I say restore this, and these two, that takes a little bit, by the way, because what SQL Server now is doing, this is, I would expect 3.5. And maybe my laptop didn't get his coffee and now he's a little bit angry with me. But I promise you the last test was 3.2 seconds, 1.5 faster than before. What happens here is the following. what SQL Server now was doing, SQL Server was investigating, hey, what are my read-only file groups, my read and write file groups, and take just only these two of them and restore them. You know what the very cool, my database is up and running. And we look to this, you see, wow, yay, they are online. This is my first one, but this is the demo, but here. You see them, they are online. So my system, I can work with it. Let's check this. So here's the first query. That would be so cool to call the manager and say, hey, here's Scotty, I really got it in 15 minutes. Ha, yeah. So he runs his query and it works. It is clear that in the moment you want to run a query which is not running on an aligned index, so that means that you do not use the partition key, that cannot work. No, absolutely not, but it is okay. Because now SQL Server needs to scan the table, but it can't because we are missing 15 file groups here. So this one here, this is a good thing. Maybe this one will work. An update, because let's say it's a production system in the chemistry, so in the pharmaceutical industry, they want to produce drugs and see this, and yay, it's working. Yeah, so we are missing over the half of our database, even more, and the SQL Server is up and running, and my database can serve the machines. I think this is so cool here, what SQL Server can do here. And now, think about this situation. You call the manager and said, hey, manager, please double my salary because my database is up and running. And then you go very calm to the kitchen, take your mug, take a little bit of coffee, a little bit of milk, zip, and go smoothly back to your desk. And then you say, well, okay, Mr. Manager, a little trick by my side. And now you restore step by step the next file groups. So this will take longer, by the way. This is a clear thing to keep that in mind. This is absolutely okay when it takes longer, because now I'm going and restoring every single file group again. And that means SQL Server will always need to access the backup file and check the file structure. And that's the reason why it takes a little bit longer, but it's okay for you because who cares? They are up and running, the system is up and running. And while the people are working with the actual data, you can restore the old data. And I think this is really a successful story here. For the for DBA
Uwe, your audio is failing. We cannot hear you, I think.
Hello?
Yeah, it might be better. Hello?
Hello?
Yeah. Yeah, so nobody can hear you really. Okay, we got a question from William Bain on the Slack channel. The recordings will be available on the YouTube channel of GroupBy. It will take a couple of weeks to process the videos, but they will be available there. Okay. So we're a bit early. Maybe he will come back. Do you have any questions? I have one here from Madhu. I can answer some of that. Not all of our production databases are in full recovery model. Depends on the use case, but from my experience, it's a bit more difficult to partial restores in this scenario. So, but maybe Uwe will come back and can answer that question for us. So, hi. Can see you, but I at least cannot hear you.
Can you hear me?
No, now I can hear you.
You can hear me, okay.
Yeah.
So then again, let me, I'm so sorry. But the good thing is that it's nearby at the end. Maybe it is a forced interruption by the internet. They don't want me to finish my session. So, and my camera is on, but I hope that it works. So let me show you one more, it's okay, yeah? So one more thing, the index rebuild, because I love this. Big databases have the problem that if you run index maintenance, it is not feasible anymore. Because let me first of all create my system here, create partition function and up to this. Okay, so when you're dealing with indexes and you come across a big table and you need to do an index rebuild, that takes incredibly much time and it takes incredibly much resources. And you can fix this problem by using the same technology with partitioning, that you can say, well, the older data, I push them away, put them in a read-write, in a readable file group, and then I have the active portion of my data, like StretchDB, and then you can put, what you can do then is, you can create, you can run index rebuilds dedicated just only for the file groups where your active data are in. So here is my process, it's done, and here is my indexes. Let me check this. And you see that it's perfectly no index fragmentation. That looks so good, but that's easy because I just have created my index on the partition. And that's the reason why you see here lots of information. I'm just only run queries against the leaf level, not for the intermediate level. So every single partition is great. Now I add a new file group because now I want to add new data to my database, a new file group for the 2020 years. Go for this, and then say use this. I split my partition function to route the new data to the new partition. Now we can start. Oh, my mouse, where is my mouse? Hello, here, okay. So here is the part. What I'm doing is I'm now creating or pushing for 1 month data into the table, which are now for 2020. Let me check what is the fragmentation step you see here. You can see this is very harmless because we just only have 42,000 rows. Everything is fine. Keep in mind that this one here is for 2020. Now we come to a bigger problem. Let me see what SQL Server will do. And you see that I do not rebuild it online. Start my transaction, make a rebuild over the whole table. And it runs and it runs. Run. That takes time. Oh, whoa. And here we can see the blockings. And you need to be a little bit familiar with locking. This is a schema modification lock. But the key point here is, look to this. It's, long story short, it is on every single partition. We completely have locked the table. Nothing is possible anymore. And that takes a little bit of time. So now I insert 6 new months. And the key point is that I'm using a uniquifier as a clustered key, very common state-of-the-art key. So for 6 months now I'm inserting the data, And now look to the fragmentation. Pip. Right. So here you see, just only keep an eye on this one. The rest is not so important, but look to this. We now have a huge fragmentation of 96%. And now you can think of the following. What about if you say, well, okay, let's rebuild the whole table again. But this does not make sense from my point of view. Let's only do this on the partition. Therefore, what I'm doing, the first step is I want to figure out what is the partition for the 2020, for the year, for the data for 2020. And this is the trick when my mouse is working. Look to this. I say, well, auto partition rebuild, but then I say, please only this partition, not the whole table. And you will see that goes way faster than it was before. And look to this. This is, doesn't it look cool? Not the whole table. Okay, we have a schema modification log. That is okay, yeah. That is by design. But the key point here is that all the other partitions are completely free. We do not take care of them. So we can write into them. We do not have any problems. And your index maintenance is now way, way faster than it is when you rebuild the whole table. That is one of the key points, what I love for partitioning. So yeah, now I'm finished, have everything. I hope that you enjoyed my session. That were some interesting stuff for you there. And yeah, if you have any questions, feel free to ask now.
Yeah, we have actually 3 short questions. Maybe there's time to answer them.
Yeah. Yeah, I see this. The first one is from London DBA. For partition aligned non-clustered indexes, do you need to include the partition column in the non-clustered index? Yes, sure. Otherwise, it's not working. But then you need to use it. But I have, let me see. We have 30. Unfortunately, one very cool thing. Only one.
I think Chris not even in. So
when will the next start? In 30 minutes?
A minute ago, but Chris is not connected yet. So
okay, so if he connect, then I immediately stop immediately. But I want just to show one problem, because when I saw this with the aligned keys, I just want to show you one problem. What I have seen so often. Is it true that filtered statistic created on partition key for each partition performance will improve? Madhu, unfortunately, I do not know. I need to check it out. I don't have an idea about this. So I'm not using quite often filtered indexes, but I promise you I will check it out. And if you drop me an email, I promise you to answer this. Yeah. Then, yeah, from mind, partitioning is a good way to take benefit in achieving data, but relationship will be the problem. Foreign key, exactly, yes. But that will work with partitioning. Yeah, that can work. How can we get my scripts? Well, very easy. I will send it on Twitter in the GroupBy hashtag. Is Chris there? Otherwise, I will just shortly show this problem. Maybe you know this. I have.
Is taking over for Chris, so he's here, but
yeah, then drop him. Drop me. So give me one more minute. Here is it.
So I feel
you know this. It's a partition table by the order date. You're looking for the max order number, okay? So here is my query, and it runs, and it runs, and it runs, and it runs. So, okay, we see that SQL Server now is reading 48,000 IOs, and if you look to the execution plan, you see a clustered index scan. So we are now the developer, and what we say, well, no problem. We create a non-clustered index on it. We looking for the order number. You see it's not aligned. By the way, if we're just looking for an aggregation, we do not need an aligned index. I want to have the last order number. So then we run this query again, and then we will see, oops, it doesn't work. The problem is using an index scan. And that is very curious, because I say, I have an index on it. Why the heck is it using a full scan? You see it here. SQL Server is scanning 21 partitions. Look to the IO. And how can you improve this? And then I'm finished. The key point is that we do not use the order date here as a filter argument. So we want to walk over all. And here is the point. Do a trick. If you if you want to SQL Server to use this index, the first thing what you need to do is figure out what partition numbers do you have here, 1, 2, and so on. This is the partitions for this index. And then the only thing what you do is, I know it's a little bit fast, but however, you now can go for every single partition and look for the max. The execution plan looks complicated, but it isn't, I promise. Look to this. Here, this is, the scan count is okay, but look to the IO. Very cool, and it's done in 60 milliseconds. Thank you, and now please hand over to Chris. Thank you so much, guys. I wish you a pleasant day with GroupBy, and hopefully next time again. Bye all.
Thank you very much. It was really great.
I stopped right. Oh, you did it, yeah?
No, not you have.
Here. Okay, I do so.
Okay. Thank you very much. It was a really interesting session.